Hi guys, so today we'll solve this question, find eventual safe state. In this question, what we have is we're given a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by a 0 index 2D array graph, which means we have the adjacency matrix. And graph I is an integer array of node adjacent to node I, means that there is an edge from node I to each node in graph I. A node is a terminal node if there are no outgoing edges, and a node is a safe node if every possible path starting from that node leads to a terminal node. We have to return an array of all the safe nodes of the graph, and the answer should be sorted in ascending order. So we have to return the safe nodes in sorted in ascending order. What are safe nodes? Safe nodes are a node for which every possible path starting from that node leads to a terminal node or another safe node. So let us take this example. In this we have this graph of 7 nodes 0 to 6. This is the adjacency matrix. We can see that 2, 4, 5 and 6 are given as safe nodes. Let me mark them 2, 4, 5 and 6. We can see that 6 have no outgoing edge. So it means it will definitely be a safe node. So this is a safe node. Similarly for 5 it has no outgoing edge. So the condition for safe node is satisfied that every possible path leads to a terminal node or a safe node. So 5 is also a safe node. From 4 we can see there is only one outgoing edge, that is to 5, and 5 is a safe node. So 4 is also a safe node. Similarly for 2 there is only one outgoing edge which leads to 5, and 5 is a safe node, so 2 is also a safe node. We see that we proceeded in a backward direction. First we saw that which all nodes have no outgoing edges, and based on them then we look for other nodes which had some outgoing edges and then mark the safe nodes. Let us look at another example. So okay, this is what we are given in the graph. This is example 2. We are given 0, 1, 2, 3, 4 nodes. Let me make the graph. This is 0, this is 1, this is 2, 3 and 4. We can see that from 0 there is a node to all the other nodes, that is 1, 2, 3 and 4. From 1 there is a node to 1, that is a referencing node, and an edge to 2. From 2 there is an edge to 3 and 4, like it goes to 3 and it goes to 4. From 3 there are two edges, one goes to 0, another one goes to 4. From 4 there is no outgoing edge. So 4 is a terminal node, so definitely 4 will be a safe node. 4 is a safe node. Apart from that, we can see that from 3 there is outgoing edge to 0, and from 0 there is outgoing edge again to 3. So it kind of leads to a cycle, and each path is not leading to a safe node. So 3 is not a safe node and 0 is also not a safe node. For 1 there is a path going to 2, and from 2 there is a path going to 3. 3 is not a safe node, so 2 will also not be a safe node, and 1 will also not be a safe node. So only 4 is a safe node in this question. Like we have here is. We are also given some constraint that graph I is sorted in strictly increasing order. That means nodes are given in increasing order, as you can see over here. And graph may contain self loop, like here it was a self loop, and the number of edges are given. Okay, so how we will proceed in this question? What we know, let me change the color. If we start from the nodes which are already terminal nodes, like which have no outgoing edge, then those nodes will definitely be a safe node. Okay, and if we first we'll see for terminal nodes, and after that if we see for rest of the nodes, whichever leads have all the path leading to terminal node, then they will also be a safe node. So how we will do is we will make an array for like to check which all nodes are safe, and we'll also make an array to see which all nodes we have visited until now, so that we don't go into an infinite loop. Let us take for this example only, like for this one. Let me erase it. Okay, so we will work on this example only. Let's say I take a safe array, like to check whether it is safe or not, and a visited array to check whether it is visited until now or not. So what we'll have is 0, 1, 2, 3, 4, 5, 0, 3, 6. Let's say this is visited array. Initially all nodes are not visited, and this is safe array. This tells us whether a node is safe or not. So let us mark it as safe. Initially all nodes are unsafe and all nodes are unvisited. So what we'll do is we'll traverse the adjacency matrix, and whichever nodes have no outgoing edges, like here 5 and 6 are there, we'll mark them as visited and we'll mark them as safe. Since they satisfy the property for safe node, so we'll mark them as safe. Then what we will do is we'll start traversing the visited array, and if the current node is not visited, like we have yet to check it, what we will do, we will start a BFS or a DFS, whichever you guys want to do. We will start a BFS or DFS from that node and see that if every adjacent node leads to a safe node or not. So let us say we do for this only, we start from 0. 0 is not visited until now, so we'll check that if all the edges which go outward from 0 are leading to safe or terminal node or not. So from 0 we can see that there is an edge going to 1, there is an edge going to 2, 1 has an edge going to 2, and 2 is not a safe node. Like, sorry, no, like from 0, one edge was going to 1, and 1 is not a safe node until now. It is unsafe until now, so it is not leading to a safe node. So 0 will not be safe node because all the edges don't lead to a terminal node or a safe node. So 0 is visited and it is not safe. Similarly, now we'll check for 1. For 1 we can see that one edge goes to 2 and one edge goes to 3. For 3 we can see that it goes back to 0. 0 is not a safe node, so 3 will also not be a safe node, and 1 will also not be a safe node. And similarly, like for 2 we will check that 2 there is only one outgoing edge that goes to 5, and 5 is a safe node, so 2 will become a safe node. And 3 was already checked, so now we'll check for 4. 4 have only one outgoing edge, that is to 5. 5 is a safe node, so 4 will also be a safe node. At the end we just traverse the safe array, and let's take another vector, we can say answer, and we'll traverse it from beginning, and whichever will be marked as safe we'll add them to the answer, like here 2, 4, 5 and 6. This way we'll get the answer in ascending order like it was asked in the question. So how we will proceed, like what is the approach that we will follow? Like I have a code written over here, we'll just walk through it. Let's say this is the function we are given. We made a safe array, we made a visited array, and we made an answer array. Initially we will traverse the adjacency matrix since there are n nodes, so we will have n rows to traverse. If the current node have no outgoing edge, that means it will be safe, like we discussed, and we will mark it as visited so that we don't need to check it again. So this is what we will do in our initial loop. After that, what we will do, we will check for all the nodes if the current node is not visited. We will take a set, and we will like call DFS. I'm using DFS over here. You can use BFS also if you're more comfortable with BFS. We'll call DFS starting from that node. We will pass a set S. I will let you know why we are using this set. We'll pass visited array, we'll pass safe array, and we'll pass the graph. These are passed so that we keep a check which all nodes are visited and which all nodes are set safe. Okay, so what we do in BFS, this is the BFS, and we will check if the node exists in the set or not. If the node exists, that means we have already visited it and we reached here. That means this path was not going to a safe node or a terminal node, so we will return false. Or we will check if the node is visited and it is not safe, then also the property is not satisfied, so that in that case also we return false. Otherwise, what we do, we check if the node is visited and it is safe. If that is the condition, means this path lead to a safe node, so we will return true, that yes, we got a safe path. Otherwise, we will mark this node as visited and we will add it to node. That means this was the path, like all the paths starting from this node has been visited, so to mark that, we add it to our set. For that, we'll take an answer array, answer variable, we'll mark it initially as true. So after that, we will traverse on all the adjacent nodes of that particular node, like this node, and if the current edge, like current node, is visited and it is safe, then we will continue. That means we need to check for other path, and if the node is not visited, we will again call DFS on that neighbor. We'll pass all these, and if the answer come false, that means if false is returned from that means it is not safe. We will mark answer as false and we will break. Why we'll break? We came to know that this path was not leading to a safe node, so the condition for safe node, that every path should lead to a safe node, is not satisfied, so we simply mark the answer as false and we break. At the end, we mark safe as equal to answer and we return answer. So like how the things are happening. Let me just make a graph and then we will discuss it. Okay, so let us say this is the graph 2 and 2, 3 has gone to 4 and 4 is to 3. Okay, so like initially this is our graph. We'll take two array, one is safe and one is visited. Let me just take them quickly. Okay, so this is visited and this is safe. Initially all of them are unsafe and all of them are not visited. We traverse over this graph and whichever node have no outgoing edge, we mark them as safe and we mark them as visited. So in this graph we can see that there is only one node, that is 2, which have no outgoing edge, so 2 will be marked as visited and 2 will be safe because it satisfies the condition of safe node. After that, what we'll do, we will start traversing and whichever node is unvisited, we will call DFS on it. So initially we came to 0. Let us say this is my set. Initially it will be empty. 0 is not visited, so I will call DFS on it, and I will check if the, since node here is 0, let me write it here. If the node is existing in S, this condition is not satisfied, or the node is visited, this condition is also not satisfied. So I'll check this, node is not satisfied, so I will mark the node as visited, so 0 will be now visited. We'll add it to the set, so 0 will not be there in the set. After that, I'll take answer variable true and start traversing on all the adjacent node of this particular node. If the current node is visited and it is safe, I just continue. For 0, I have two neighbors, 1 and 2. Since I get 1 first, 1 is not yet visited, so this condition is not satisfied. I will call DFS on this, passing 1 as the node and the rest are our same. When I will come on 1, these two conditions will not satisfy, so I will add it to my set, mark 1 as visited, and then after that, let me just clear it. Okay, so I came on 1, this is not satisfied, this condition also not satisfied. I will mark 1 as visited and I will add it to my set. After that, I will see for all the neighbors of 1. For the 1, we have only one outgoing edge that leads to 2. So like 2 is visited and 2 is a safe node, so I will continue. 1 have only one neighbor, so answer will remain true only. At the end, I will mark 1 as safe and I will return safe, like I will return true. So I came back to 0 now, it returned true, so it means that yes, this path was leading to a safe node. So this path is verified now. Now I will check for this node, like this edge, it leads to 2. 2 is a safe node and 2 is visited, so I'll not call DFS, I will come out of this loop. Answer is true. So 1 will also become a safe node. After that, I come back here and now 0 is visited, 0 is safe, 1 is visited, 1 is safe, and 2 is visited, 2 is safe. So now I came to 3. For 3 is not visited, so I will again call DFS on it, making a new set. This time set is again empty, so I will call DFS. This base condition is not satisfied because 3 does not exist in the set, and also 3 is not visited, and 3 is not safe and 3 is not visited, so this will also not satisfied. Now I will mark 3 as visited, so 3 is visited. After that, what I will do is I will check for all the edges of 3 and I will call DFS on them. Since there is only one neighbor for 3, that is 4, so I will call DFS on 4 now. When I reach 4, I see that although it does not exist in my set and it is not visited, so this will be not satisfied. This condition was also not satisfied, so I will mark 4 as visited and I will call DFS on the adjacent nodes of 4. For 4, I can see that there is only one outgoing edge that leads to 3. 3 was already visited and 3 is not marked as safe until now, so I will return false from here. So for 4 I got false after the DFS call. I will mark answer as false and I will break. So like the 4 will be marked as not safe because there was an edge going to 3 and 3 is not a safe node, so 4 will also not be safe node, and from similarly for 3 there was an edge going to 4. 4 is not a safe node, so 3 will also not be a safe node. So this is how we will get which nodes are safe and which nodes are not safe, and this is the way we can get what all nodes are safe. And we, at the end, what we do, we just traverse the safe array, and if the current node is safe, we just push them to answer. This way we get them in ascending order as well.